Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video explains how to work one very obnoxious homework problem involving relative risk and the odds ratio. Let's get started. Okay, so this obnoxious homework problem, I've just seen students just, ready to tear their hair out when they see this. I don't know why they're assigned this. This is actually much more complicated on the surface than what it really is. So here's our problem statement. In a clinical trial of 2248 subjects treated with a certain drug, 26 reported headaches. In a control group of 1578 subjects treated with a placebo, 21 reported headaches. If the proportion of headaches in the treatment group is P sub t, and the proportion of headaches in the control group is P sub c, then the relative risk, a measure of the strength of the drug treatment, is P sub t over P sub c. Another measure is the odds ratio, which we'll show you later. Okay, so first we're asked, what is the relative risk for the headache data? Well, they give you the formula you need for relative risk. It's here in the problem statement, PT over PC. So all you have to do is just write that out. PT is defined here as the proportion of headaches in the control group. So the control group is this right here. There's 1578 total and 21 report headaches. So that proportion for the control group is going to be 21 over 1578. The same goes with the treatment group. You've got 2248 total, 26 of them are reporting headaches. So 26 over 2248. In a way, the proportion is calculated the same as a probability. We're looking at the part over the whole. So once we get to this point, now all we have to do is the math. So fractions within a fraction mean you're going to take that fraction on top and multiply it by the reciprocal of the fraction below. So I take the fraction below, I turn it upside down, that gives me the reciprocal, then I multiply straight through. 26 times 1578, 2248 times 21, divide that out, and I come out with 0.869. There's your relative risk for the headache data. Now, what's the odds ratio for the headache data? And the problem that you're given, they give you this obnoxious formula that you have to use, which is this right here. And I call it obnoxious because it's not really that complicated, but it's just a pain. Because here you've got, again, fractions within fractions. So we just take this a piece at a time and we can actually whittle our way to the answer. So when we plug in the numbers that we need, here's what we get. So this proportion, P sub t, we're just taking these numbers here, 26 divided by 2248. That gives me this number here, 0.11566. Okay, 1 minus that, so 1 minus 0.011566 is 0.988434. I do the same thing down here with the control group. So 21 over 1578 gives me 0.013308. And then I subtract this number from 1 and get 0.986692. So when you divide all this out, and I just punch this out on my calculator, this just makes it easier. So I get 0.868. There's my odds ratio. So now the last part of this problem usually asks you for some sort of real-world interpretation. So here I've got in the table the results from the clinical trial. These are the values that we just calculated on the previous slide. So the question that's asked for the interpretation is, what do these results suggest about the risk of a headache from the drug treatment? And you're given 4 different options to choose from. The drug appears to pose a risk of headaches because PT is greater than PC. Well, PT and PC are about the same value. You can see that from the table up at top. They're relatively the same. So there's not going to be anything huge. If anything, PT is slightly lower than PC. So the treatment actually has a little bit of effect in lowering the headaches proportionally from the control group. So if anything, you could say the treatment is somewhat effective at reducing the number of headaches. So it's not going to pose a risk of headaches. So answer option A is not going to do for us. Answer option B, the drug has no risk because the relative risk and odds ratios are almost equal. Well, yeah, they are almost equal, but that doesn't mean there's any risk. Okay, the risk level is determined by the proportionality. To use the relative risk or the odds ratio to let you know if you have risk is like you're looking for something that's, essentially over 1. And since the numbers that we have here are less than 1, that's saying that we don't have any risk of increasing that condition, which in this case is the headaches. So B's not going to work. Answer option C, the drug appears to pose a risk of headaches because the odds ratio is greater than 1. Well, that's obviously not true. Our odds ratio is 0.868. So C's not going to work. That leaves us with answer option D, the drug that does not appear to pose a risk of headaches because PT is slightly less than PC, and that's exactly what we see in the table. 0.012 is slightly less than 0.013, and that does mean that the treatment is lowering that proportion of the sample that actually experience headaches. So answer option D is going to be the answer that we want to select. This is a really obnoxious problem. I don't know why people keep assigning it. I don't even know why it's there to be assigned to begin with. But if you run across this problem, this is how you solve it. And that brings us to the end of this mini lecture. I really do hope you found this one helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.